Hello learners, welcome to Sure Question Academy. Please watch the videos, like and subscribe to the channel.
Let's solve this question about simple machines. Part A. A wheel and axle system is used to lift a load of 500 kilograms. If the radius of the wheel is 0.8 meters and the radius of the axle is 0.2 meters, what is the force required to lift the load? Let's answer Part A. Given data for the wheel and axle system. Mass of the load, M, is 500 kilograms. Weight of the load, W, equals M times G. 500 times 9.8, which gives 4,900 newtons. Radius of the wheel, R, is 0.8 meters. Radius of the axle, R, is 0.2 meters. We know that mechanical advantage is equal to the radius of the wheel divided by the radius of the axle. MA equals 0.8 divided by 0.2, which equals 4. Now, the force required or effort is equal to the load divided by mechanical advantage. F equals 4,900 divided by 4, which gives 1225 newtons. So, the force required to lift the load is 1225 newtons. Or, you can choose to answer Part B. A force of 100 newtons is required to push a load up an inclined plane of length 5 meters and height 3 meters. Calculate the mechanical advantage of the inclined plane. Let's solve Part B given data for the inclined plane. The effort force, E, is 100 newtons. Length of the inclined plane, L, is 5 meters. Height of the inclined plane, H, is 3 meters. Mechanical advantage is equal to the length of the plane divided by its height. MA equals 5 divided by 3, which is approximately 1.67. Therefore, the mechanical advantage of the inclined plane is 1.67. Thank you. Happy learning.